Check. Check what? Checking the audio. I think everything is fine. Right. So we'll start today's work. Sorry for the delay. We had a technical issue. It's not completely solved, but I think things are pretty much manageable. Yeah. So you can hear us clearly, right? No issue, ne? Shape ne? පුළුවන් විදියට කරන් යන්නමයි. මේ Yeah, so before starting now, the normal time schedule will be 7:30, right? 7:30 to 10. Sorry, 9:30, because we have the QBR for the 27 students starting at 9:30. For them, we only have the QBR session every other week because they have the paper class, right? So this week we don't have. Luckily, we don't have the QBR for them, so no issue. Hari, yeah. Before starting, I assume all the technical issues are managed. Shape කියලා හිතනවා. Then yeah, what happened? හරිනේ. Okay. So before starting, what is the QBR? What we do here and all. So since we started a little late, we'll continue until around 9:45 today. Normally it will be at 9:30. Hari? So for someone who is joining without knowing what the QBR is and what is going on, I'll give you a brief introduction on what we are doing. Hari? Okay, right. What is the QBR? Why we do this? What we do this? What we do here, right? So the idea is for QBR, and I guess if you have any questions, YouTube Lamai can send it to the YouTube chat. And if you are joining from Zoom, you can send it to the Zoom chat. So I'll be personally responding. We don't have anyone here in like the normal class. So I'll take 5 minutes. Okay, so QBR stands for question based revision, and what we do here basically is we do questions. Here it's just a normal, this session doesn't have a guideline or a plan. We really don't have a plan. Now in the theory class, we have a plan. We have to finish this unit by this time. So today I will do this, and I even prepare for those sessions. But for QBRs, no preparation, no nothing. I just come and discuss some questions. That's what happens. But since we need a rough guideline, so that you would know what we do, we will be first discussing the past paper questions for every unit, and that will be mainly MCQs. Later we will be focusing on structured essays and essays. The reason for that is for the first few units we really don't have a lot of structures and essays. So mainly we'll be covering the MCQ part first. Then once your term tests are nearby, we'll be focusing on the term test papers a lot more than the past paper questions. So that will be the main outline. And other than that, if a student sends me a good question which I think of discussing it here, I might say today we are not doing any past paper. I'll just discuss this question. So it is that kind of a session. Alright, that's fun. And on the other side, let's say if I feel like your simplification skills are not enough and all, I might be focusing on that on a particular day. And then when are we going to have this session? Every Saturday, 7:30 to 9:30, every week until your paper classes start. Once your paper class start, it will be every other week, because when your paper classes start, we have the theory session, we have the paper class, and then the QBR. So it will be a little bit too much for you. We have to manage the other subjects as well. Then the session will be every other week. So every other week after paper classes, normally your paper classes will be started around September. We'll see. I haven't confirmed it, but after that, it will be every other week. So that is the entire plan. And for today's work, yeah, I think those are the main things you need to know. Should we get a separate book for the QBR? I think that's up to you, I guess. If you're now, when we are discussing the MCQs, if you need to write anything, if you need to write a review or some kind of an explanation now about reviews and all, we'll learn later. No need to focus on those. So what you should do is, every week I'll be sending a PDF or a paper or something to the group. You can complete that, you can go through that, make sure to go through it, right? Otherwise it won't be that effective. If you are seeing the question for the first time, then it won't be very effective. Ne? Go through it and then join, and then we'll be discussing some of those MCQs. And then if you want to write something, you can have a separate book. Yeah, no need to write it inside the theory book. Yeah, you can have something like a small book separately if you want. Yeah, your choice. Here we don't have any guidelines. Yeah. So this will be very important. I took a book to write. Good. So this will be very important for you because you need to realize. I on the first day said these small kind of sessions will improve you a lot without you even noticing. In the term test, you will have a massive advantage. You will realize it on that day. Now every week you won't feel anything very special. We will be doing a very little bit of work because for 2 hour sessions we can't discuss a lot of questions, but since it is compiling every week, you will be doing a lot. Hari? Right, now what is the schedule for today? For the first 1 hour and 30 minutes I will be discussing the tute, and then in the last 30 minutes I will be teaching you how to do the log simplifications. Now if you know how to use log and if everything is fine, no need to stay in that last 30 minutes. Hari? Only the students who have issues with log, or even maybe the London O-level students who haven't done log simplifications, which is important in locals, you can stay and you can get that part, right? Hari? I think everything is clear. Then I guess all of you have the tute. If and always try to get physical copies of these tutes, I think it's good for you. I can't deliver from every tute to tute. Ne? You understand that? So if possible, it'll be better. Right? Okay. Hurry. Okay. Then I think we can start work. Yeah. Anything else? What is it? Yeah. Hurry. So all of you have the tute. Then I'll start. I still didn't get a hard copy of the tute. I'll get it soon. So I'll just use a soft copy for the discussion. Sorry. And if you have any questions, you can send it to the maker, right? Okay, the chat. So we'll start. Okay. So we have about 20 questions from what we have done in Unit 1. Normally for the last 10 years, there were about 35 questions. At the moment, we can do about 20. I think we didn't have 35, around 30. Then you can do more than 2/3. So I'll start from the easier ones. Did everyone do the tute? I guess. Karane the tute. You should, right? Alright. Then I start from question number. So first we'll exclude the questions with quantum numbers because we did it yesterday. First we'll discuss the other questions and then we'll see what we can do about quantum numbers because this is new. You are new to this. Ne? Muling anit tika karalemu. Then shall I start from question number 20 and go backwards? Come to question number 20. The 20th. It says, what does it say? The de Broglie wavelength of a neutron traveling with a velocity v is lambda. The kinetic energy E of this neutron is increased 4 times. The new de Broglie wavelength will be. Now, we learned this also yesterday regarding the wave particle duality found by Louis de Broglie. What was the equation we learned? Lambda is equals to h over p. Lambda is equal to the. Is the board mirrored? Or are you seeing it properly? අනිත් පැත්ත ගහලා වගේද තියෙන්නේ? Because what I can see is mirrored. නෑ නේද ළමයි මේ it's correct නේද? හරි නේද? Clear? Okay. හරි. Clear නම් හරි. Okay, shape. Okay. Then here what they are saying is considering a neutron, right? Considering a neutron, if at the moment the velocity is v, We can rewrite this P as mv, right? So this is from this is from yesterday. Mass into velocity. And then the velocity is v. The kinetic energy E for this neutron is half mv squared. The kinetic energy is half mv squared, right? Half mv squared. And then of this neutron is increased 4 times. The new de Broglie wavelength, right? Now, if you need to, now you know the kinetic energy. Now, we didn't write this equation. I expect you to know this from all levels. Now, if the kinetic energy was multiplied by 4, they are asking what happens to this wavelength, this, right? This. First, we need to find what happens if the kinetic energy is multiplied by 4 here. What should we do? Now, this is multiplying the kinetic energy of a neutron. Now, can we multiply or can we change the mass of a neutron? No, right? We don't have the control. The neutron has a given mass. You can't change it. So, for this case, this is a constant. You can't change the mass of a neutron. That's common sense. Ne? Then to multiply the kinetic energy by 4, you have to multiply the velocity by what? 2, right? Because it's a square. Ne? You no need to multiply the velocity by 4, just multiplying it by 2 is enough because it has a square. So that is done. So what basically happens is the velocity will be multiplied by 2. Now, if you want, you can write an equation, but without writing an equation, you can look at here and say, h is a constant. H is a constant, right? Regarding this case, m is a constant because we can't change the mass of a neutron. Then what changes is the velocity. What changes is the velocity. Now again look at the equation. If the velocity is multiplied by 2, what happens to the wavelength? Will it be multiplied by 2 or divided by 2? It will be divided, right? Because the velocity term is in the denominator. Let's say I'll write something like this. 1000 divided by 2 is 500. If I multiply this side by 2, then it's 1000 divided by 4. Then that will be given by this divided by 2, no? So similarly, if I multiply this side by 2, this should be divided by 2. I guess that's very clear. Then the new lambda is lambda divided by 2. That's not very difficult. Right? So very simple questions. Under 1 minute, I want you to get the answer. Right? So the answer for the 20th will be the first. Now, if someone is doing these past paper MCQs using a Pesuru book, sometimes your answers might be wrong. The Pesuru answers can be wrong. And one more thing. Now, since some of you are interested, if you can buy or if you can have the past paper MCQ books, it will be easier for you. Then no need to depend on the document I send to the group. Now I send the relevant questions, but you can do more if you have it. So no need to buy, for chemistry, no need to buy the structured essays and essay books right now. If possible, no, it's not compulsory, but if possible, if you can, having the past paper classified MCQ book is better. For these sessions, it will be better. So if anyone is interested, you can send a text to our number. I guess all of you have the number. Then we can let you know some places we know. Right? It's not some kind of a advertisement. We just know some places, so we can let you know those. That's it. Same idea regarding the resource book. Again, it's not compulsory to have the resource book, but since some of you are interested, there is a standard place to buy the resource book, but most probably it won't be available there. Then I can try and find some places. So if someone knows places to buy these resource books, just let me know. Because if you are just send me the place with the district, because we are teaching the entire country, so saying a place in Nugegoda won't fulfill the need. So if you want to know a place, send a text. If you know a place also, send a text. That will be a massive help. I can't promise I'll solve it immediately, but the Pesuru issue we solved last year. Last year I went hunting and found some places. A place where you can order online, a place in Nugegoda, and we found. We can do that same for the resource books, because resource books are not available everywhere, especially the English medium version. Right. Then that's the 20th. That's the 20th. Then the 19th. It's okay, no? Yeah. Shall I move with the 19th? Hurry. For the 19th, it says what does it say? Consider the following discoveries made with regard to the atomic structure. Positive rays inside the cathode ray tube, radioactivity by certain types of nuclei. The two scientists who discovered the above 1 and 2 respectively are. So positive rays inside a cathode ray tube, who found it? That was found by Eugene Goldstein, right? Eugene Goldstein found positive rays first. He conducted those experiments first, and then later Ernest Rutherford concluded the proton, but the positive rays were found by Eugene Goldstein. So answer number 1, 2, 3, 4, 5. Who has Eugene Goldstein? So 5J4. Sorry, there's only 4 J.J. Thomson wrong. 3 Henry Becquerel wrong. 1 J.J. Thomson wrong. So it's only 2 and 5. 2 says Eugene Goldstein and Robert Millikan. 4 says J.J. Thomson and Ernest Rutherford. That should be the answer. Sorry. 5 says, no, wait. 2 says Eugene Goldstein and Robert Millikan. 5 says Eugene Goldstein and Henry Becquerel. Henry Becquerel found radioactivity. So that's correct. So the answer is the 5th. That should be by like 5 seconds. Hari. Then the 18th. Consider the following statements 1 and 2. Now, if you know that you knew this but you couldn't remember the answers, you better use the first page of the tute. You can tear that page and you can paste it somewhere with all the names. And you will easily remember those. These are very small things but matters. 18. Consider the following statements 1 and 2. The energy absorbed or released by atoms is quantized. Hari, we learned this the week before yesterday, no? So it's talking about the quantization. Small particles under appropriate conditions or wave properties. That is the wave particle duality, right? The two scientists who proposed this. First one, the energy absorbed or released. Now, if they, the first sentence is a little bit tricky. In your term test, this can be questioned. If the word quantized is given, who gave the name quantization? Who talked about the quantum? That's Max Planck. If it is about a quantum, then that is Max Planck. Or even discrete energy, that first idea was given by Max Planck, right? But if it is about a photon or a packet, the same concept, same term, synonyms, true, but these names were given by Albert Einstein. So you need to read it and answer accordingly. If they ask for a photon, then Albert Einstein. If they ask for a quantum, then it is Max Planck. Hari, එහෙම එකක් තියෙන්නේ. Then here the first answer is quantum, then it is Max Planck. Then wave particle duality is Louis de Broglie. So first one Max Planck, second one Louis de Broglie, then the answer is 2. Then the answer is 2. Right. So that's the 18th. Then come to the 17th. There's a small issue in the 17th. It's not 1 into 10 to 1020. It's 10 to the power 20. That part has not been superscripted. You can change that. That should be 1 into 10 to the power 20. So come to the 17 quickly. Any questions? Sir, you are fast, sir. Still didn't write review for 18. Is there anything to write for 18? It's just 2 names now. You just need to write this was found by this, that was found by this, right? Be a little bit fast. Couldn't find the English medium version of Pesuru. Yeah, then just text that WhatsApp number. We'll help you. Sorry? Okay. Then the 17th. The 17th. I forgot. No, I have the hard copy. Where is it? Okay. Then the question 2017 12th. A lamp produces 6 joules of energy per second in the blue region. They have given a wavelength of the visible light. For how long should the lamp be lit to generate 1 into 10 to the power 20 photons? We did a very similar kind of question. ළඟින් යන එකක් කරා නේද? මතකද? Yesterday in the weekly paper. So you can see the questions are very similar. So it says a lamp produces 6 joules of energy per second in the blue region, 470 nanometers. So that is, it's like 6 watt, yesterday, 6 joules per second. The lambda is given as 470 nanometers. Lambda is given as 470 nanometers of the visible light. For how long should the lamp be lit to generate 1 into 10 to the power 20 photons? Okay, 1 into 10 to the power 20 photons should be generated. Right. So first you need to find how many photons are generated per second. Right? You need to find per second how many photons are generated. Then you can find how many seconds do we need to generate that many photons. They have given a value. So how to find that? Just consider 1 second. 1 second, what is the energy? Per second, what is the energy? 6 joules, right? Per second, the energy is 6 joules. Hari. Then, what is the energy of 1 photon? These two E's are not the same, right? I'll put it as E naught. So this is the amount of energy that is emitted per second. Then you can find the energy of 1 photon. So that is 6.626 into 10 to the power minus 34. Now no need to put units. Why? Because these are MCQs. C is 3 into 10 to the power 8. Lambda is 470 into 10 to the power minus 9. Lambda is 470 into 10 to the power minus 9. Harida? You can simplify this and find the energy emitted by 1 photon. Right? You have to be quick. Find the energy emitted by 1 photon. So when you are simplifying this, shall we try to do some shortcuts? I mean, to make things easier. So I want simplify. I'll keep it like this. 6.626. I can write this like this. I will write this 470 like this. So 470 into 10 to the power minus 9 can be written as 4.7 into 10 to the power minus 7. Right? Then instead of simplifying this entirely, I'll keep this part and the 3 without simplifying. So I have 6.626 over 4.7 into 3. Then I'll just simplify the powers of 10. 10 to the power minus 19. So this is the energy. This is the amount of energy in one photon, contained in a photon, right? එක photon එකක energy එක මේ තියෙන්නේ. This is the energy contained in one photon. හරි. Now how to handle this? You know the total energy per second, right? Now what happens? Now you can hear, no? Yeah. Sorry. So this is the energy in one photon. This is the total energy per second. Then we can divide those two. So you will get 6 joules divided by, no need to write the joules as well, divided by 6.626 over 4.7 into 3 into 10 to the power minus 19. What is this? The amount of photons emitted per second. The amount of photons emitted per second. Hurry. Right. Now we have to try to simplify this. මේක simplify කරන්න try කරන්න වෙනවා. Hurry. Okay. So you can see this will go up. This will go up. So it will look like 6 times 4.7 divided by 6.626 into 3 into 10 to the power 19. What is this? This is the amount of photons emitted per second. Check whether you understand that. So how did we get this? This is the amount of energy emitted per second. This is the energy that is contained in one photon. So the division will give us the amount of photons emitted per second. Now you should not be afraid to do these simplifications. Come to this point, still we haven't solved this. So what I am trying to do is, rather than simplifying the answer here, I am trying to drag it down to the final answer. So in the final answer, I will have a large expression, which is comfortable for me. If someone is comfortable with simplifying this here, you can do that. But I am trying to see whether I can approximate the answer rather than just simplifying it. Anyway, now we know in 1 second, this many photons will be emitted. In 1 second, this many photons will be emitted. Method 10, come to this point. So I'll be going a little bit slowly today. Now you can hear, no? So will they give us logbooks in MCQ paper of A level? Yes, they will give more than a logbook. It contains a lot of tables. I'll show you such a book later. It's not the normal logbook you buy from the bookshop. It's different. When do you have paper classes for 2020? Okay. Hurry. So this is the amount of photons per second. Now what are they asking for? They are asking for how long should the lamp be lit to generate 1 into 10 to the power 20. So we need this many photons. We need this many photons. Per second, this much will be emitted. Then to find the amount of seconds, you have to divide this by this. So again, don't be afraid. Write this long expression. Okay, now you can simplify this. This and this will cancel. I'll use different colors. These two will cancel, giving a 10. And then this part will come up. I guess you know those. This will come up like this. So that is 6.626. If someone has issues with these simplifications, ask. Because it might not be log all the time, Hari. Now, without using a single simplification, I have just worked with the powers of 10 and then I have just dragged it down to the final answer. This is the final answer. This is the final answer. Now, I don't know if I am lucky, I'll be able to just look at the values and tell the answer. For that, two things, I mean, one thing needs to be assured that the answer should be very not competitive. So if the answers are very close answers, then you can't do that. Don't risk it. Then you will have to use log and multiply this. True. If not, you can do that. So the answers looks fine. Can we? Okay. There's one thing where we can simplify. Me. You can cut 6 and 3. So now it is 2. Then what you have is 6.626 multiplied by 10. 2 times. Okay, 2 and 6. This also goes like this. 5. Okay, things are a little bit easier now. Now I have 6.626 multiplied by 5 divided by 4.7 into 10. Harida. 10 10 was cancelled now. Okay, right. Yeah. So 6.626 into 5 it can be easily calculated as 33.13 divided by 4.7. Now 30. Okay, right. No, measure on it. Look at this. 5 divided by 4.7 should be slightly above 1. So you will be multiplying 6.626 by something slightly above 1. So obviously it's not 10.5. It's not 2.4 either. It can be 7.1, 8.5 or 9.2. If I was doing the question and if I was under time struggle, I would put 7.1. Harry? Because this value is very close to 1. 5 divided by 4.7 is very close to 1. It's is it 1.1? Around 1.1. So 1.1 multiplied by this is around 7.1. Now, if you are not sure about it, don't take a risk. You can simplify this. But the whole point of these sessions is to try to go to the other level rather than just simplifying these and wasting time. Harry? So, just try to improve your skills so you can stop the question here and say it's 7.1. Harry? How did I do that? 5 divided by 4.7 is very close to 1. Then 1 times 6.6 plus something, some little bit. But if the answers were like 7.1, 7.0, 7.2, then we don't know. Then we can't say that. Alright, so try to learn that idea. Okay, so the answer for that should be second. I don't know. I'm guessing. I think it should be the second. Yeah. Take down this if you have anything to. You can't see the entire calculation at once. So you had to start from here, find the energy of one photon, then divide it, find the number of photons per second, and then divide it by the total requirement to get the time you should spend. Now, most of you would spend about 5 minutes doing this. But the student who has improved simplification, who is not afraid, 30 seconds. So that student has extra 4 minutes and 30 seconds to spend on thinking. You might be smarter, you might know more chemistry. That's not what we want. I mean, it's good, but this is much better. Hari? Okay. I'll give you a few minutes. If you have questions, ask. No, I'm not planning to finish the entire tute today. So what's the time? It's 8:26. Ne? That means if we are finishing the session at around 9:45, we'll continue this until about 9:15, the question discussion, and then I'll do the log part. All right. So after the session, the remaining questions you can do at home, and then we'll discuss it next week. Right. So for the entire unit, there is about 35 questions max. 20 is on the tute already. Yeah. Right. Daras as the book, I got it through there. Okay, okay. Then students, if you need, you can check that. Hari, then. Then, okay. Anything else you want to know? Can't hear you. Colin. Cannot understand 20. Yeah, if you have any issues regarding not understanding anything after the session, just send me a text. Can you tell that multiplication by 4 in the 20th again? Okay. Was that difficult? What's the page number? This is the last page of the tute I gave you. For Pesuru books, just send us a WhatsApp text. How would we? So I am getting a lot of messages which are not relevant to this session, like how to get tutes and all. So those students, please text here, right? Because I don't know the answers actually. So are these A-level past paper questions? So no, this is school. Sorry, these are A-level past paper questions. So this is the 2020 A-level. No, the one we did now is 2017 12th question. Right, we'll be doing past term test questions as well. Here, these are past paper questions. From the last 10 years. For every unit, with that unit, I will be covering all the term test MCQs, sorry, the past paper MCQs for the last 10 years. That's the plan. Hari? Yeah, so here one student wanted me to show this part. Now the idea here is now to multiply the kinetic energy by 4. If the mass is a constant, you have to multiply the velocity by 2 because it has a square. When you multiply the velocity by 2, that 2 will be squared and then this will be multiplied by 4. That's what I said. Then here, so after finding the amount of energy per second, there's nothing to find, it's given for 6 joules per second. This is the amount of energy in one photon. So this divided by this will give you the number of photons emitted per second. Then this part is the total photons we need to emit. This part is this, which is the number of photons emitted per second. Then once you divide these, you will get the total number of seconds. Hari? Ne? Energy per second, energy of one photon. Then you will get how many photons were emitted per second. Then the requirement of photons divided by how much photons are emitted per second. Then you will get the amount of seconds. Right. So if someone wants me to write it in words, energy emitted per second divided by per second. But energy of a photon. So how do we find this? This is 6 joules, that's given. This is H. This is a much more clear way, ne? Yeah, Hc over lambda. So in these sessions, I am trying to be a little bit unclear because these are MCQs. No point writing all of these and solving the problem. But if you want, I can be clear. Then once you get this entire value, I'll take this entire value. Once you make a divided by this as x. Nah, sorry, so this divided by this will give us what? photons per second. Photons per second. If someone can't understand anything, just write down this and go and read this again. Then, after you get this, total photon requirement, that is what? 1 into 10 to the power 20. That is also given. That is given. Divided by photons per second. That is the above ratio. Photons per second. Above ratio. This entire thing. You will get the answer. Right. Now it's clear. No? Even for someone who doesn't understand anything, you can just copy this and go and read it again. Okay. Then shall we move on? I'll give like 20 seconds for someone who is struggling. Then I'll move on. Then shall we try 16 or shall we? No, we'll first finish the questions which doesn't have quantum numbers. Then we'll go to the 15th. We'll try to finish those first. Alright, 15th or 10? 15th then? Alright? 15th. Some of the students had asked whether the recordings of these sessions are available. The answer is yes, in recordings නම් තියෙනවා මේකේ. But I think I don't want you to watch a recording of this session because I mean, why? No need to pile all of these recordings. I guess that's not how it should be done. Anyway. Answer number, sir, please. Say, sorry, I didn't. What is Emma? I didn't understand. How does 10 to 20 10 to the... No, it's not 10 to the power 10. It's just 10. It's not 10 to the power 20 divided by 10 to the power 90. It's just 10, not 10 to the power 10. It's just 10. Just 10. Huh? Alright, enough time. 15th question. Now, since you are asking where are these questions from, which means still you are new to this. 15th question is 2014 36th question. Now you get the context. Right. It's 2014 36. Which of the following statements? Now, all of these questions are on the tute. I guess all of you have the tute. Past paper the tute was sent to the group yesterday. Which of the following statements are true with regard to the electromagnetic radiation of wavelength 200 nanometers? Right, 200 nanometers. Okay. It has a higher frequency than radiation of wavelength 400. That we know, right? We discussed that idea. So it's C equals F lambda for electromagnetic. This is a constant. So if the lambda is higher, frequency is lower. That we know. So regarding the 200 nanometer wavelength wave, it has a higher frequency than a 400. 400 is higher than 200, then the frequency of 400 should be less. It has a higher frequency than radiation, that's correct. B. It is in the visible region of the electromagnetic spectrum. Can you remember the region? For visible region, I ask you to remember the range. It's 400 nanometer to 750. Now we are not talking about a 400 nanometer wave. Now reading the first statement, you might mistakenly take it. But we are talking about a 200 nanometer, so that doesn't belong. Visible light region is from 400 to 750 nanometers. Right? Then the C statement. In a vacuum, it has a higher velocity than radiation. No. All the waves, all the electromagnetic waves in a vacuum has the same velocity, which is this. That is also wrong. D. its photon has a higher energy than a photon of radiation of wavelength of 100 nanometers. No, right? Now, if you want to convert the photon energy using wavelength, this is the equation. We know this. Now, we use this. In this case, H is a constant. C is a constant. Both H and C are constants. Both H and C are constants. Then higher the lambda, lower the energy, or lower the lambda, higher the energy. Now the wave we are talking is 200 nanometers. In the D statement, it says its photon has a higher energy than the photon of radiation of wavelength 100 nanometers. So the wave they are giving is 100. So that has a lower lambda, then it should have a higher energy. Ne? So try to understand these relationships. Lower lambda, higher energy. Now the wave they are giving is 100. So 100 nanometers means lower lambda, ne? Rather than 200. Right. That means this statement is wrong. Ne? Photon has a higher energy than a photon. No, it's wrong. Yes. The wave with 100 nanometer should have a higher energy rather than the 200 one. Yes, but it's in this says 200 one has a higher energy, which is wrong. So this is the combination. It's A is correct, B, C, D all are wrong. Now the answer is not A. Did you realize that in this question you only have 4 answers? So there's a way to answer these questions. I'll teach that. Before that, quickly write down this. Quickly get the answers. Then there's a way to answer these questions. It's not just the answer is A. So I still can't understand that multiplying thing. Yeah, then just send me a WhatsApp text. Because we can't be over and over explaining the same question. No, it's unfair to the others. Will you be sending the recording to the group? Yes. Explain C again. In a vacuum, it has a higher velocity than a radiation. No, the idea is simply all the electromagnetic waves will have the same velocity in a vacuum. Any wavelength. It's just this value. That's the C statement. Huh? Why can't we use de Broglie equation for part C? Because you can't use de Broglie equation for part C because you don't know how to substitute. How to substitute? For an electromagnetic wave, what's the mass? Is it 0 then? So those are some complications which you can't touch. That's why it won't work. Good question. You don't know the masses. It's a wave. We normally consider waves have 0 mass. But the de Broglie duality says something a little bit different. We can't we change momentum by velocity? You can, but without knowing the masses, how can we substitute here? And again, the velocities are the same, no? Still, nothing will change. Velocities are same. You are saying since the lambda is different, the velocity should change. No, you can't do that because then what about the m's? Are we completely ignoring the fact that m is 0 for a wave here? You can't do that. That's a good attempt. But no. The decimal and power divisions are a bit confusing. Is there a way after class to explain? Yeah, in the last 30 minutes, we'll talk a little bit about simplifications. Here, the D statement again. So this is the equation which explains the energy of a photon. The idea is if the lambda value is higher, energy is lower. If the lambda value is lower, energy is higher. Now we are supposed to compare two waves with lambda equals 100 nanometers, lambda equals 200 nanometers. Since this has a higher lambda, energy of that should be less. So energy of this, I'll put it as E2, energy of E2 is less because the lambda is higher. But the statement says that the energy of a 200 nanometer wavelength is larger. That's wrong. It should be smaller. Right. Now, does anyone know how to answer the questions with 4 answers? Can you just react if you know how to answer? The answer is not A. Does anyone know how to answer a question with 4 answers? The 27 students, if anyone is here, might know, correct? Now, this is what we do. Now, this is something general. In your paper, in your paper, the first 30, paper means A-level paper, right? Now, when we start paper classes, at once you won't be getting a 50 MCQ paper. But the full paper has 50 MCQs. The first 30 MCQs have 5 answers. The first 30 MCQs have 5 answers. It's simple, the answering structure is simple like O levels. You select the best possible answer and underline it. That's it. That's how it works. Then from question 31 to 40, you have 4 answers like A, B, C, D. This is how the answers go. Now the instructions will be provided, but no. Normally with practice, students will remember this. If the answer is A and B, if the answer is A and B, then we underline 1. We underline mean in the checkbox we cut 1. You get a sheet, no? You have to cut the answers. So after you answer the question, if the answer is A and B, then the answer is 1. If the answer is B and C, the answer is 2. Let's say they ask for the correct statements. Then statement A and statement B are correct. Then the answer is 1. Statement B and statement C are correct. Then the answer is 2. Statement C and statement D is correct. Then the answer is 3. A and D is correct. The answer is 4. You can write down this if you want. Anyway, in papers, this is given. Anything else? Any other combination? The answer is 5. Any other combination, the answer is 5. This is the set of instructions to answer questions from 31 to 40. Now, this is from 31 to 40. It says the 36th question, 2014. So, in our case, what would be the answer? May look at our answer. A and B, no. B and C, no. C and D, A and D, this is other. This is none of the 4 combinations, so our answer should be 5. Is only A is correct, so the answer is 5. That is how we answer these questions. So it checks whether you know all the answers correctly. Now for the first 30 questions, only knowing the correct answer is enough. Here it's not enough. You need to know about all 4 statements. There can be multiple answers. Right? Is that clear? Understood, ne? Right, you may write down that. Then we'll go to the next question. So that is the 15th. Then we'll do the 12th and the 13th. Write down this. Yeah, any issues up to now? Anything? Sir, 40 to 50 question format also, yeah, it's again different. 40 to 50 questions are more different. When we come up with such a question, I'll explain that. Without a question, it's difficult to explain. No need to be worried. These are very common things. You will get used to this. For physics, you don't have such a structure. It's just 50 straight 5 answer MCQs. For maths also, we don't have MCQs anyway. For bio, you have a different structure. I guess it's a little bit more complicated than that's what I have heard. I did maths, so I don't know. But for bio also, you have a different structure like this. Bio students normally say it's a little bit more trickier than, we don't say this difficult, it's trickier than the chemistry. Pen check, I don't know. 31 to 40 questions, always statement questions. Statement can I think sometimes the statement might have a calculation in it. Ne? Now, even the ones we did had a roughly a calculation related idea, no? But not a long calculation. Yeah. It will be 4 separate statements. Yes. It might have some calculation ideas. Yes, that's a good question. So we don't need to write the combination when the answer is no. You will just get a makeup nenne. Anything, you have to just cut the answers. So probability wise, if you don't know the answer, just cut 5 because probability wise it has a higher chance of occurring. Anything else except for these 3 combinations, these 4 is 5. If one answer is correct, it's 5. If all the answers are correct, 5. If 3 answers are correct, 5. If A and C is correct, it's 5. So there are tricks like that. We'll later figure out those. If B and D is correct, 5. So if you don't know the answer, it's 5. Probability wise, it's better. They're not seen. Right. Then shall we move on? Okay, then come to question number 12 and 13. So I have skipped 2 questions. I skipped 14, which is quantum numbers, and I previously skipped 16 from quantum numbers. Come to question number 12 and 13. On the tute, question number 12 and 13. Question number 12 and 13 on the tute is 2012, 18 and 19. So it's not really the last 10 years. It's even older. Because for the first few units, we don't have a lot of questions in past paper. So I had to go a little bit beyond the last 10 years. Right. Hari. So they have given a paragraph. It says, read the paragraph and answer the questions. When light strikes on a certain metal surface, electrons can be ejected from it. Okay. The energy carried by photons in light is transferred to electrons in the metal. And if the electron acquires sufficient energy to overcome its attractive forces with the positively charged nucleus, it may escape from the surface as a photoelectron. The minimum energy required for electron to escape varies from one metal to the other. No need to completely understand this. This is called the concept they are talking here is called the photoelectric effect. You will learn that in physics, I guess, in the last unit. Hari? So the basic concept is if you have a metal here, no need to understand the concept. The metal surface contains electrons which are attracted towards their nucleus. Hari? If you give a energy sufficient enough to break that attraction, these electrons can emit. The minimum energy we should give is known as the work function. You haven't learned any of that. In physics, you will learn. So if you give an energy higher than the work function, these electrons will be removed. That's called photoelectric effect. Shape, no? Right. Now, no need to know that, but just a brief idea. Then we'll... Right. Then I will discuss this. The energy required for photoelectrons to be ejected from the surface of barium is 240 kilojoules per mole of electrons. That means to remove 1 mole of electrons from the surface of barium, barium is an element, you need a minimum of 240 kilojoules. If you give something less than that, electrons won't remove. Sorry? If you give something higher than that, that extra energy will also do something. Let's say you give 300 kilojoules. The minimum is 240. Then what happens to the other 60? You will learn in physics. Sorry, no need to know that as well. Anyway, anything less than 240 will not do anything. The minimum frequency of light capable of producing a photoelectron in barium is. So, the question hasn't clearly mentioned this, but the idea should be now to remove 1 mole of electrons. To remove 1 mole of electrons, we need 240 kilojoules. So the question has assumed to remove 1 mole of electrons, we need 1 mole of photons. Otherwise, you won't get the answer, I guess. Have they mentioned it? When the light strikes, electrons can be ejected. The energy carried by photons in light is transferred to electrons in the metal. Not really, no, they haven't really said that. I don't think we can just apply 240 kilojoules. No, yeah, you have to assume it. It's not given. It should have been given. So the idea is 1 photon. Now it's not clearly given. I guess it should be 1 photon of energy will remove 1 electron. So 1 photon is responsible of 1 electron. Another photon is responsible of another electron. Another photon of another electron. So basically, to remove all of the moles, I mean remove 1 mole of electrons, you need 1 mole of photons. That's not given. Alright? But we'll understand it like that. To remove 1 mole of photons, 1 mole of electrons, 1 mole of electrons, 1 mole of photons required. Hari. Ne? Hari. Now you know how to calculate this. Can you remember? You can write the energy of 1 photon. Now I'll write it in sentences. It's clear for everyone. Energy of photons. Never do this in MCQ, right? We won't be writing anything. If you can directly write E equals HF, HC over lambda and get the answer, get it. No need to do this. Hari, මේවා කරන්න එපා. Hari. Energy of one photon is what they're asking for a frequency. Ne? Energy of one photon is HF. Then energy of 1 mole of photons. That is what? HF times the Avogadro constant. Ne? HF times Avogadro constant. Right? So this is the energy of 1 mole of photons. These can't be new now. So this should be equal to what? The minimum we need 240 kilojoules per mole. This is the minimum we need. 1 mole of photons should give that minimum. So your equation should be H times F times the Avogadro should be equal to 240 kilojoules. You have to convert it to joules. Yesterday we learned that. SI unit simplifications. Right. That's it. So H is 6.626 into 10 to the power minus 34. F is F. Avogadro is this. Now I want you students to be able to write this equation at once and then this and get the answer. You should practice enough, so you should won't be writing any of these. මෙතනින් උඩ මුකුත් ලියන්න එපා. MCQs වල පුළුවන් තරම් නොලිය ඉන්න. Try not to write things. So you should be only writing these two. හරි? You can simplify this and get the answer. Again, we'll try to simplify this. We'll try to get the answer without simplifying. But before that, in your review or something, you may write the question doesn't clearly say this, but we assumed it. That 1 mole of electrons are removed by 1 mole of photons. In other words, 1 photon is only responsible about removing 1 electron, not the entire mole. Hurry? That won't practically happen. Right. The Sorry? Finish this, get the answer. And I'll show you a few tricks again here, simplifying. Can we write Na as L? Yes, Avogadro constant can be written as L. Correct. Now, now how to simplify this easily? So a student who is doing well should not be writing anything from here, just this. Mekat puluwan nan, try to visualize it and write this at once. Good then. Then the frequency is given by 240 into 10 to the power 3 divided by 6.626 into 10 to the power negative 34 times this. First simplify the powers of 10. First simplify the powers of 10. Then you will get 10 to the power minus 11, 10 to the power 14 times. So this and this and this. Then you will get 240 divided by 6.626 into 6.022. So roughly in calculations, especially in MCQs, remember the product of this, product of the Planck constant and the Avogadro, the first parts, not the powers of 10. This is roughly 40. 39 point something. Knowing those will help you. The product of this is roughly 40. Now 6 times 6 is 36. This is 6.6 ne? So I just give you the value 6.626 into 6.022. That's 39.9. So almost a 40. So if we consider this as 40. So these are some shortcuts. 240 divided by 40 is 6. But if the answers are like 6.01, 6.02, then don't do that. But the answers won't be like that. You can see the answer. Here you have the 10 to the power 14. 240 divided by 40 is 6. So it's 6 multiplied by 10 to the power 14 frequency units per second. Can you see without simplifying how to get the answers? You can. Not in every question. Don't try this in every question. Nah? Right. Now you can hear again. Sorry, the audio, we have some issues today. So make sure to do this, learn this simplification. So it's 40 into, sorry, not 40. 240 divided by 40 is 6. 6 into 10 to the power 14 per second. Right? Not very difficult. Do this quickly. Hurry. Then the 40th question. The 40th. So the answer for the 39th, not the 40th, it's in here. Sorry, the 12th, ne? 12th, ne? I can't remember. Yeah, the 12th question, the answer was 4. Be very careful because the second answer is, sorry, the second answer looks like the same. The power of 10 is different. The maximum wavelength of light that can produce this effect in barium. Now, the idea is this is the minimum frequency we need to provide. What is that? 6 into 10 to the power 14. Why? If we provide a wave with a lower frequency, what will happen? Then the energy will not be enough. Ne? So here, now this is a constant, F is the minimum frequency. If you provide a higher frequency, then the energy provided will be higher than this. Okay. But if we provide a lower frequency, the energy will be less than this. So actually this is the minimum frequency we should provide to remove electrons. Minimum frequency means what? Can you remember? If the frequency is minimum at that point, that gives the maximum lambda because this is a constant. So again I'll repeat, we need to find the maximum lambda which enables this. That means if we find a higher, if we give a higher lambda than our answer, what will happen? Then the frequency will further drop. That won't be enough to fulfill the energy requirement. That won't be enough to fulfill the energy requirement. If the lambda is higher than the answer we are going to get now, the frequency will be lower than this. Then the energy will not be enough to remove the electrons. See whether those things are clear. Right? So it's not very difficult. C value you know. F is this. You have to find the lambda. Here it's very easy. Lambda is equal to, so this is 0.5 10 to the power minus 6. That's 5 into 10 to the power minus 7 meters. You can convert this to nanometers by multiplying this by 10 to the power 9. That is 500. I expect you to simplify at this rate. If you are unable to do, we have to practice. Practice will make you good at simplifications. So that is 500 nanometers. So anything above 500 nanometers won't give this frequency. Then the energy won't be enough. So for that question, the answer is 3. Okay. So you may ask anything. I can repeat anything. So we'll do 1 or 2 more questions and then we'll learn a little bit about simplifications. Right? Yeah. I am planning to start the simplifications part around 9:15 and then to do it for 30 minutes. Hari? I didn't understand the simplifications. Yes, okay. What part didn't you understand? What is the difficulty? So you have to put some effort on your side as well regarding simplifications, because I am not here for that. You need to understand that. But I'll do something here. So we don't need to write the combination when the answer is 5. Yeah, I think I answered that. That's an awesome trick. Thank you. It's not awesome. It's just a basic trick. You will learn much more better tricks later. Didn't understand how you got 40. I just knew it. I didn't get it. So, mehemane, now always in A levels try to be smart. This is not a very smart move, but compared to what you know at the moment, this is sort of smart, right? So, in all these E equals HF and Avogadro questions, it's pretty annoying when you get these two values, right? It's very difficult to simplify, right? So, for MCQs, just remember the rough value, it's 39.9. So, if the answers are not competitive, then it's 40. Then you can easily get the answers. It's just a small thing, a small adjustment we do. That's why I tell you, always try to work alone. And I always say this, right? Keep in mind, from our side, we try to give you the best. We have a theory session, we have this session. Later also I'll be having this session, that session for the students who can understand quickly. We'll have separate sessions. Students who need help, we'll have separate sessions. So I'll try to give my maximum, because that is my job here. But one thing you shouldn't forget is, every class, I mean not every, but a lot of classes provide this. Not in chemistry, I mean in any subject, any stream, anything, right? But still the amount of A's are very little. That's the reality. That's the reality. No matter what we do, how hard we try, still the A percentage for chemistry is 7%, which is the highest. For physics, it's around 4%. Sometimes it's 5%. Then for bio, it's again around 4. In some streams, there are subjects, the A percentage is around 1%. What does that say? That means you should work on yourself. So the final result will be determined by how well you work. So when you start working on yourself, you will realize things like this, which might not be taught in a class. There can be things which we haven't realized. When you are doing a simplification, you realize, which is a personal thing. For me, thinking about a question like this is better. In the class, a different method was taught. So always keep that in mind. It's important to join these sessions. It's important to join the theory class properly. But a lot of students do that. That's not enough. That's like the minimum. That's not enough. I'm just speaking the facts. That's just statistical value. About, I guess, about at least 60%, 70% students join classes. But only you have 6% days. There should be a reason for that, no? We can't blame the classes for that. I don't think so. The classes are doing their best. But it seems it's not enough. Maybe that's how A-levels work. So always try to work alone. That will improve a lot. 0.5 into 10 to the power 6 is minus 6 is 5 into 10 to the power minus 7, not minus 5. Here it's 0.5 10 to the power minus 6, that's 5 into 10 to the power minus 7. Cutting simplifications prashna diyana. Hurry. Then 12th harine. Then come to the 11th question. That's a new question. 11th. 11th question. Eleventh question is from 2024. 2024, fourth question. 2024, fourth question. Now, where is that? I found it. Nice. Sorry. The de Broglie wavelength. The de Broglie wavelengths of two particles X and Y are 1 nanometer and 3 nanometer respectively. If the mass of X is 3 times the mass of Y, the ratio of kinetic energies of X and Y would be. Alright. Now here you need to learn how to do this, how to handle such questions. This is the 11th question on the review. That's 2024, fourth question. Sorry. 2024, fourth question. Okay. එතකොට right. So here it says the de Broglie wavelengths of two particles X and Y. Right. Now what we can do is, now some students can just look at the de Broglie equation and the kinetic energy equation separately and try to work this. That's okay. But I'll try to combine this, then it's easier for me. For some, you can look at this and get the answer. That's also fine. Some can do that. But in one way, it's easier to explain if I can combine these two equations. Now, how to combine the equations? Now, in the question, what have they given? For X, they have given the lambda. Then for X, they have given the mass. They have given the lambda and the mass. Alright. So look, now look what I'm going to do. You will learn these ideas in physics as well. I can combine these two equations. See how I'm going to do that. If I subject M, I can write it as h over lambda v. I can subject M and write it as h over lambda v. Then I can substitute this term instead of M there. I subject M from here and then substitute this term there. Like this. E equals half times, instead of M I can write this. This is M. Then V squared. Then I will get half H V. V to V will cancel and 1 V will be left, this. So now in this equation I have combined the lambda and the kinetic energy. But this equation won't help me. Why? This is not the correct way to combine the equations. Why? Can someone tell me why quickly? For this question, this is not correct. The equation is correct, it won't help me. Why is that? What is the reason? Yeah, correct. They haven't said anything about the velocities. They have said something about the masses. Neither. Correct. So this way of combining will not work. This will work if they had said about the lambda and the velocity. So you need to know what to do. So this is also correct. This won't do what we need now. Then we'll try to do it in another way. Again we'll try. Lambda equals h over mv, E equals mv squared. In the data, they haven't said anything about the velocity. So we can remove that term. And we should remove it because it's not given. Velocity දීලා නැහැ, මොකුත් දීලා නැහැ. Yeah, nothing is given now. How to remove velocity? Subject v here. H over m lambda. Then substitute v. E equals half times m. V squared is the square of this. That is h over m lambda squared. No need to write it this. If someone can directly imagine what v squared is, you can simplify and directly write the answer. Just understand, I am teaching everyone. If you can do it better, do. Then half m h squared m squared lambda squared. I subjected v, then I have this, then I squared it, right? Then simplifying this will give me half h squared m lambda squared. Now check whether you understand that. So I have E equals that equation. Check whether that is clear. බලන්න එක තේරෙනවද කියලා. And the velocities of two electromagnetic. Yeah, these are not for electromagnetic waves. They haven't said that. These are just for normal waves. These are not electromagnetic waves. And they haven't even said these are particles. Sorry. Yeah, it should be particles. Otherwise, you can't apply this because the mass, we don't know that. Right. Now, the equation we have is this. E equals, don't study these ideas, because from question to question, it's different. For the other question, this might be the equation. E equals this. How can you remember this even? This is the equation we need. Now it's very easy to compare. You can see that the h is a constant. No need to worry about h. This is a constant. Then the masses and lambda values are given. You can compare. How to do that? Once you get the answer, once you understand. So what did we do? We subjected v. Why did we subject v? Then I can substitute v. Why did we do that? Because v is not given. Right? Then once I get this equation, I can write me E1. The first particle E1 is half times h squared times the mass is what? It says if the mass of x is 3 times. So I'll write it as 3. Come on, man. If you want, you can write 3x. Same thing for MCQs 3. The mass is 3. The wavelength is 1. For x, the wavelength is 1. So 1 squared. This is E1. For E2, half h squared. Now a student who understands, no need to write this part entirely because both are the same. Anything. Half. Then here the mass is 1 here because x is 3 times the mass of y. So if y is 1, x is 3. Wavelength is 1 for x but 3 for y. And you can divide these two to get the ratio. You can divide these two to get the ratio. Then even, so these parts will entirely cancel out. Then here it's 9. 9 divided by 3. The answer will be හරිනේ 9. So it will be මෙහෙම එකක් එන්නේ. E1 divided by E2 will be 3. So the ratio between, so it's 3 over 1 නේ. E1 to E2 වෙන්නේ 3 to 1. Check. So you can see how important the simplifications are going to be, right? තේරෙනවනේ සිද්ධිය. How to simplify this? මේක කොහොමද මේ simplify වෙන්නේ? When you are dividing this, it's E1 over E2 equals, this is 1 upon this is 1 upon, so this part and these parts will be gone. Then this part will come on top. මෙහෙම එන්නේ. නේ? Over this. So that is 3. This. So that is 3 means E1 over E2 is 3 over 1. 3 means 3 over 1. Then we write the ratio like this. Okay. So the answer should be 3 to 1. Then it's answer 4, not answer 2. Be very careful. After doing all of that, no need to get the answer incorrectly. Ne? Right. So we didn't do a lot today, but I think shape ni ටිකක් කරා වැඩ. Yeah, there are few more questions from the parts which are not what do we call it, quantum numbers. We'll do those next week. So by next week we have the theory class now in Friday. Then you will have a better understanding on quantum numbers as well. Then you can do those. Then we can finish. Probably we'll be able to finish this entire tute next week. Then we can do the other part. There are the other questions from the last part of the unit. So we have about 3 more weeks of work for unit 1. Not a lot. 3 over 3 weeks. Then we can finish the tute parallelly, the unit parallelly. Sorry. Can you explain the division part? Oh, මේකද? Now, being honest, I would prefer if someone can, here මේමයි හරිද? ඇත්තම කතාව. After getting this equation, someone who has trained enough can write this directly. මේක එකපාර ලියන්න පුළුවන්. හරිද? So that's the goal. Set higher standards. After getting this, your brain should be able to process. This is a constant. Make a constant. Then E1 over E2 is equal to, අර මේක 1 upon නිසා the mass 1 lambda 3 mass 3 lambda 1 කියලා you should be able to try to visualize it and write. I really can't explain how that is done. It's not that simple, but once you are trained looking at this equation, looking at the data sets, you should be able to write this at once. That requires some practice. ඒක පුරුදු වෙන්න. Simplifications are going to be massive. හරිද? Now if you want me to explain how this was simplified, මෙහෙමනේ. So the equations we got, E1 is equal to h squared 2 times 3 times 1 squared. Then E2 is equal to h squared 2 times 1 times 3 squared. When we divide these two, what happens? How to divide two fractions? E1 divided by E2 is equal to, make a h squared 2 times 3 times 1 squared multiplied by the reciprocal of that. So that is 2 times 1 times 3 squared divided by h squared. This divided by this is equal to this multiplied by the reciprocal of that. Then you can simplify. Then you again get this thing. Simplifications මාර level එකට ගෙනියන්න පුළුවන් ළමයි, right? I haven't shown you a lot yet, but you can. At my peak in A levels, I had a very good ability to simplify. That made me a lot of time to think the other parts. I might not be the best in chemistry, but my simplifications were good enough. When the others were thinking, when the others was simplifying, I was thinking. Got the answer first try. Why? What is the issue? So yeah, now you are not sure about how you got it. Is that the issue? So y is E1 1 times. No, I substitute the values. So here 3 is the mass. Now make a the data says mass of x is 3 times y. Make mass of x is 3 times y. Then the wavelengths are given as x has a wavelength of 1, y has a wavelength of 3. ඒක තමයි උදාලා තියෙන්නේ. හරි? හරි නේද? Check that. So I know we haven't done that much in chemistry, but I already feel dumb. That's good. ඉක්මනට තේරෙන තරමට හොඳයි. හරි? I don't know the answer in the my question. It somehow the answer is 3 to 1. Fourth, ne? This one. Hari? Then if someone wants without doing all of this combining, you can do it like this. So there are multiple ways. හරිද? මේ එක විදියක් කියලා එකක් නෑ ඉතින්. Isn't x equals 3y, Dan? If the mass of x is 3 times the mass of y, so it's x, it's x equals 3y තමයි. So this is 1, this is 3. And this is x, this is y. එහෙම තමයි. මෙහෙමත් පුළුවන් ඉතින්. Lambda is equal to h of mv, then E is equal to 1 half mv squared. Without combining the equations also, some of you might be able to just look at these two and get the answer. That's also fine. ඉතින් එහෙම අනිවාර්යෙන්ම combine කරන්න ඕනි කියලා එකක් නැහැ. But for most of you, at first, just looking at these equations and getting the answer will be difficult. That's why I didn't do that method. So no need to. You can just combine the equations very quickly and then get the answer. That's easier. Hari? Hari. Hari. And then if you are saying that you got the answer correctly in your method, but you got it incorrectly using this method, you can use your method, the thing, but you should get the answer correctly in any method. So you will get the answer today correctly, but not correct tomorrow. Okay. And then that's enough for today regarding the questions. So I want you to try these again. I know these questions, the remaining questions you can try. And here you should have realized the issue is with not theory, with simplifications and understanding a calculation. We haven't even started real calculations. So try to understand things quickly. Then I'll take another 20-25 minutes and discuss a little bit about simplification. So if you are smart enough to understand simplifications, you can leave the meeting. It's fine. Anyone who wants simplifications can be on the meeting. එතකොට හරි simplifications. First, tell me what are the issues you have regarding simplifications. What are the issues you have? Now I initially wanted to have a log simplification discussion and end the session. But it seems the simplification issues go more beyond that. Ne? Log විතරක් නෙමෙයි බැරි වගේ එකක් තියෙන්නේ. General simplification issues you have. What are the issues you have? You can just send it to the chat. So that means we won't be able to finish simplifications in one day. We'll just do some part ideas whenever we are free. Whenever we are free. කියන්නේ මේක නිකන් ජොලියට කරන session එකක්. We'll do it here. Decimal multiplication. 10 to the power values. Okay. Log simplification. Decimal. Right. Yeah. Hurry. May. So first thing you need to realize that anyway you can't, improve simplifications in one day. That's number one. And after a certain level, simplifications cannot be taught. It's called intuition. You need to feel now, okay, this is the best method here. That comes with practice. Sorry. So mainly your issues are some things like log simplifications. You have log simplifications. Then you have powers of 10. Ne? Power simplification. Then you have things like dividing or multiplying decimals. Things like that. Ne? Hurry. Henang, I think I'll try to reach the how to solve using log. We'll see whether we can share a document, a logbook. I assume you have the log sheets. Otherwise, you think you can Google the log tables. Balo. Me 2 minutes. I'll share the log tables. So I'll be doing log simplifications today mainly. Then later we'll work on the powers of 10 and decimals, and even some of those will be solved after learning log properly. I'll share the log simplification table, and within 15 minutes we'll be finishing this. Yeah. This is the log table. We can but I'll make it a little bit clear. මේක තව dark කරොත් පේනවා හොඳට. මාව කළු වෙනවනේ කවන්නේ. හරි. This is the log table. Now we have some limitations. There's a certain range where I can write හැමදේම ලියන්න බෑ මම හිතන්නේ මේකේ. It's a PDF no. Anyway, I'll give you an understanding on how log works. First we'll start with the basics. So what I am going to do is I am going to show you how a normal simplification is done. Are we getting the same orange colored log table we got for levels? I don't know what you got for levels. Color orange. Isn't there any other short method to multiply numbers like 3.89? I am really bad at, yeah. So my my advice is, if you find a better method to multiply 3.88 into 5.59, just a random multiplication, rather than using log, that means only one thing. That means it is not a better method. You are very bad at logs. Log is the best method. When a mukut methods nahi. I mean, like there can be some shortcuts for given specific examples like we used in the MCQs. But for a random decimal simplification, mechara idi anything. If you have a better method, that means your log simplifications are terrible. This should be the best method. This should be the efficient method. Hari. What I am going to do is I will show you how I don't know how to operate this that much. Hari. I will show you how to do a normal question. So what we'll do is we'll do a normal question today. I'll start from A to and finish to Z. I'll finish the entire scope. Then later I'll give you one example question. You can go and check that at home. Let's say you were supposed to find the value of something like this. This is completely log. And one thing you would realize later is log is not there to be used for the sake of using log. Sometimes you should learn how to multiply it manually. Let's say like this. Right. Now you are expected to simplify this. හිතන්න මේක ඔයා simplify කරන්න ඕනේ. ඇදයි නේද සැහෙන්න. Is it my issue? නෑ මේකේ මේ පොඩි ඇදයක් තියෙනවා. මේක ලොකු කරා මේක පේනවා. හරි කවන්න. Who cares? හරි කවන්න. හරි මේ බලන්න, you are expected to solve this. First thing, we don't apply log to the 5. Why? We get the value of this part and multiply it by 5 later. Now you can, if you want, you can get the log of that as well. It is time consuming. So you need to have that common sense to remove the parts which doesn't require log. Don't use it for the sake of using log. Log dunnam me mulu ekatama log danne. Don't apply log here. That's number one. Then we are going to find the value of this part using log. Then the next thing is, most of you having issues with negative antilogs. So the simplest way, avoid it. Avoid getting a negative antilog or avoid getting a bar. How to do that? Always make sure before applying log that the numerator is smaller, the numerator is larger than what? The denominator. එකනේ මේ යට පොඩි වෙන්න ඕනේ උඩට වඩා. Now do we need to simplify that to? No, you can just check 2 times, even 3 times 3 is 9. This is way larger than that. So how to do that? I can rewrite this part like this. So first I remove the unnecessary parts. Then I am rewriting this as you can, if you are terrible at powers of 10, still this will be difficult, but most of you are comfortable. I wrote this like this. Then I can take the power of 10 away. You can do this, ne? So the 10 to the power here in the denominator, when you put it up, it's 10 to the power negative 2. Again, if you have issues with powers of 10, we'll check that later. I guess that's fine. Now again we are applying log only here. Now it seems fine. This value should be closer to 8. 3 times 3 is 9, so it should be larger than this. Then the numerator is larger. So the very important step is always try to avoid getting bar values. It's a trouble. No need to. I have never got a bar value in log calculations. Just avoid it. Now you have this. Now we have to apply log. So the idea is this. Now log has some theories. I'm not going through all of that. The simple theory is this. Log now we are using log base, right? අපි use කරන්නේ base එක. The log base 10. Even we are not writing the log tables, all are prepared for the base of 10. මේ බේරවන්න හරි. The concept is this. Log A times B is equals to log A plus log B. Also, log A divided by B is equal to log A minus log B. හරිද? Log A times B is equal to log A plus log B. Log A divided by B is equal to log A minus log B. So we are basically applying that here. So what I am going to do is, this multiplication can be written as a sum. This division can be written as a subtraction. Even let's say that is not clear, මේකත් තේරුන්නේ නැහැ, ඒත් කමක් නැහැ. You need to find the log values of these three separately. Hari, first we'll do that. You have to find the log of this, log of this, log of this using the log table. Now I guess all of you have the log sheet. It's easier for you, then you can do it with me. So we started from here, remove the 5, make the numerator larger than the denominator to avoid the bar values. Now we have this. Now we have to find the log values separately. Hari? You can speed up the process once you understand things. Hari. Now what are the values? I'll take a photo of the values, otherwise we'll have to go back and forth. Karadarai. Right. So I have to find the logs of these three numbers. Now the first value we are supposed to find the log is 2.87. පේනවනේ පොඩි මේකක් තියෙනවා පොඩ්ඩක් බෆර් වෙනවා මේක. But I think you can see and all it's good shape එකේ තාම move වෙනවනේ. හරි. 2.87. Now look at this column. Even though this column says 10, 11, 12, it is actually 1.0, 1.1, 1.2. So there's a imaginary decimal point here. Hari? Imaginary decimal point එකක් තියෙනවා මැද්දේ. So it's 2.87. Then you have to find 28 because 28 is 2.8. Now මොකේද බලන්න මතක තියාගන්න value එක 2.87. හරි? ආවා. 2.8. This is 2.8. හරි? Then 7 ගන්නේ උඩින්. Now since you can't see all of it at once, මේ බලන්න. I'll show you once මේ. 0, these columns are named 0, 1, 2, 3, 4, 5, 6, 7. ඔහොම යනවා. හරි? So you can remember the columns now. Name මෙහෙමනේ ගියේ. This column was 0, 1, 2, 3, 4, 5, 6, 7. This is the 7th column. 0, 1, 2, 3, 4, 5, 6, 7. 2.87. So this is the value. Now still we did not use this. We'll check when that can be used. Hari? Thama naha eka. Harida? Right. So this is the log value of 2.87. 7 naave uding. Now your table you should have it. No need to me udata pahalata yanna ඕනේ. ඔයාගේ කිව්වට පේනවනේ. So this is the value. Remember, the log table, the values inside the log table will only give decimal points. Everything after the decimal point. 1 point, 2 point, 3 point, ඒව දෙන්නේ නැහැ. It's everything after the decimal point. Hari? So what is the value? Remember? Now you can see it in your table. It's 4579. 4579. ඒ කියන්නේ whatever. No. I'm very scared to touch any of this. මේක ගියොත් එහෙම හරි ප්‍රශ්නයක් වෙනවා. Can I cut this? Alright, shape. 4579. Then again, if I switch here, the log of this is 4. I'll use a different color. This is better. The log of this is 4579, that is 0 point. All the logs you find, the part you check from that table is less than 0. Sorry, less than 0. Now 1 point can be highlighted. Then methana 2.87 Sorry, this is 2.87. Let's say somehow you wanted to find the log of 28.7. Hari 28.7 බලන්න ඕන කියලා හිතන්න. From the log table you can only find the log values from log values under 10. මේකේ log එක හොයන්න බෑ. So you can write this as 2.87 into 10. Then the log of this we found. Log of 10 is 1 because 10 is 10 to the power 1. Log of 10 is 1, log of 100 is 2. Even if you don't know why, we'll explain those later. Log of 1000 is 3, log of 10,000 is 4. Then the log of this is 1.4579. So if you wanted to find the log of 287, that would be 2.4579. That can also be mentioned. හරිනේ. එහෙම එක ඇල්ලකුත් තියෙනවා. Anyway, I found the log of this. Okay, now I'll give some time, try to find the log of 2.63. No need to send the answer. Just do that because I know you, it's better to give you some time. මේකත් තේරුණාන්නේ? If we multiply a certain value by 10, the log value will be increased by 1. Now we can discuss why that is in a conceptual way, but for the moment just we'll do this. හරි. ගන්න බං. Get the log of 2.63 quickly. Can you explain what happened to that 5? Nothing happened. We just removed it. We'll multiply it manually later. No need to apply log for a easy value. Wasting time. So we won't get questions to find the log of negative number. Negative numbers do not have logs. Or you can't express a negative number in log. Can't, ne? All the numbers. Yeah. Negative numbers do not have logs in real numbers. Later in maths you will learn imaginary numbers, but still I don't think we'll go. 0.42. Okay. Others? Did you get the value 0.42? I don't know whether that's correct. I'll check. I'll give you 1 more minute for that. If you are done, you can take the log of this as well. Make a log එකත් බලන්න. හරි? හරිද? එතකොට 2.63 කොහමද බලන්න? 2.63 මේ 2.6 0 column 1 column 2 column 3 මේ 4200. So that is 0.42 නේ. That is 0.42. හරි. That is 0.42. So the log of this is 0.42. Then finally 4.388. Again, if we were supposed to find the log for 26.3, then the log will be 1.42. If the log was 2630, then that will be 3.42. So this part won't change. Only the front number will be changing. 4.388 log goemu. 4.388. 4.388. Then balanna me. So the value we are supposed to find is 4.388. 4.3 hari. 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. But that's only 4.38. Anit ata enne metanin. You need to check this column to get the other 8. So you got 4.3 from here. 8 from here. The other 8 you should get from here starting from 1. The column starts from 1. So you have 4.38, 1, 2, 3, 4, 5, 6, 7, 8. It's again 8. Then how do we combine these two? We add those two values. So that's 6, 4, 15 and 8. That's 6, 4, 23. Ne? මේ දෙක එකතු කරාම එනවා 6යි 4යි 2යි 3ක් 6 4 23. That is the log. That is how we use that column. හරිනේ එනවනේ 6 4 2 3 එකක් නේ. Nice. Good. Right. If you got 6 4 2 3 then correct, then we can move on. හරිනේ ආවනේ තේරුණානේ මෙතනින් ගත්තා 4.38 and the remaining 8 you have to add those. එකතු කරන්න තියෙන්නේ. Then that's 6 4 2 3. Put a buffer වෙනවා we can't temperature වැඩියලා හවුලන්නේ. 6423. So that is 0.6423. Now the initial work is done. You have found the log values. Now you have to add the log values for a multiplication, reduce the log value for a division. So the final log simplification would be 0.45. In your paper, they won't give a single mark for simplification. So no need to write any of these. These are just in your rough sheet. So you write this and then the final answer. All of this is done in a rough sheet. No need to write any of this. 0.42. So this plus this minus this. Now here I think you have to try to simplify quickly. So this plus this will give you 0.8779 minus 0.6423 will give me 0.2356. Try to reduce from front to end, from start to end. Normally you start from this direction and start subtracting. This is a little bit efficient. So 0.2356. You can't use log to simplify this. You only can use log to simplify multiplications or divisions. For additions you can't. So that is the next part. Once we get the log values, we simplify it. So if something like 4.3886 is given, how to simplify? Good question. Now here, if it was 4.3886, you can't check this value from the log table. Then first you need to round this off. 4.3886 is equal to can be rounded off to 4.389. Then you have to find the log for that. There will be a small error, can't help. Anyway, the log table has a small error. It's not accurate as the calculator. For the third decimal point 4, there will be some errors. Like log not like a computer. No? Yeah. So this, if you get something like this, then you have to convert this to 4.389. Then you have to use log. Hari? Good question. Yeah, now, so if we get 5 digits in decimal, how to get? Now you got the answer, right? So what about the 5 you started at this? No, we haven't done. Once we'll get the final answer and then it will be multiplied by 5. So you get this. Then come to this point. Then okay, if this is clear, mega harinam. Now, once you get this, now you have to convert this again to the correct value. So we converted these to log values. Log values are actually powers of 10. Now, if someone is wondering what are these values, I'll just, no need to know this, but I mean, no need to know this now, but you should know what you are doing. So the meaning of saying the log of 2.63 is this. If someone wonders what this actually means, what the log table does, this. The 0.23 power of 10 is 2.60. So you can plug this in a calculator, then you will get the answer. Make 10 to the power 0.42 gahanna calculator, you will get something close to it. Not exactly, something close to this. Okay. That is the value, that is the idea of log. So what we really do is we convert these numbers to powers of 10. And you know multiplication of powers is addition. So you can express this multiplication as addition. Now that's what we do here actually. We write all of these numbers as log values or powers of 10. Then instead of multiplying we can add. Instead of dividing we can subtract. That's what we do actually. Anyway, now normal values, log values, you have got the final log value. Now you have to convert this again to a proper value. That is called finding the antilog. So you have to find the antilog of this. Again we use the log table. Now remember the value 0.2356. Okay. 0.2356. We again go to the log table. But this time, so what was the value? 0.2356. This time we pay attention here because now we need to get the antilog. To get the log, we go from here to here. But to convert it again, we go from here to this value. So you have to find this value. Search 2356 here. Math de balan. If you can't exactly find 2356, find the closest low value. 2356. This is the closest value. But it should be less. Now let's say the value you were supposed to find was 2379. The value you were supposed to find 2379. You can't get this. That is higher than that. It might be closer than this, but it is higher. Anyway, our value is okay. It's 0.2356. This is what you should look at. So find that value. Then again, similarly, you have to read this column and the top column. So you know this column was named as 0, 1, 2. So once you get 2355, methering 1, 7, that is 1.7. Remember the imaginary decimal point. So this is the first column, sorry, 0 column, first column, second column. So another 2 comes, but that's not enough. Why? Our value was 2356. It is 2355. So you have to add another 1. 1 nang add කරන්න බෑ ඉතින් 3 එකක් වගේ තියෙන. So you can just ignore it. You can just keep it as it is. අවුලක් නෑ. So actually you should add another 1. It's 2356, but in this column we don't have any ones. So you can just stop it here. Let's say our value was 2360. මෙහෙම තිබ්බ කියන්නේ 0.2360. Then 1.72. Methering you have to add this 5. Then it's another 2. So it would be 1.722. In our case, no need to. Just keep it like this. 1.72. So this is the value. This is the antilog. That is the answer. Not done. Can we add positive log with negative add log? Can you do a negative log question? So my point is, why do we need a negative log? When we can avoid it. I can show that next week, but always try to avoid it. So if we don't have a log table and we somehow have to multiply hand, can we round off all the decimal numbers to 1 or 2 decimals? No, you can't. There's no scenario as having no log table. In every exam, a log table will be given. So log නැති situations නෑ. For a term test, you have to carry your log book. Log tables නැති case එකක් ඉන්නේ නැහැ කවදාවත්. You should have, right? So it's 1.72. Now again, this is the answer if this was the value. Let's say once you add those values, the log values, and reduce, you got something like this. You got 2.2356. Still you find the antilog to this part, then you will end up getting here. Then what do we do to do justice to the sec 2? The 2 here. 2 is 10 to the power 2. So you have to multiply this answer by 100. So if this is the value, the antilog is just this. But if this is the value you got 2.2356 එකක් ආව නම් you have to multiply this value by 100, then your answer is 172. ඔන්න ඔහොමයි log simplify කරන්න. That's it. So I gave a brief understanding on how to use log for a basic calculation. Yeah, log is just the power of 10. Yeah, that's a very creative way. හොයාගත්තට පස්සේ it's easy for us. But it's a very creative way of looking at maths. magic table again. How did people know these values? No, these are just powers of 10. So basically we are writing the values of given in powers of 10, then again converting it back. So sir, while checking anti-log, shouldn't the value even increase by 1 from the original targeted log values? This which means should it only decrease? Yeah. You should always go for the lower value. Otherwise, how are you going to add that from here? Now you should go for the lower value and the difference should be added. Again, 2, 3, 5, 5. What we need is 2, 3, 5, 6. Then we have to add that 1 from here. But 1 is too small, so there's no column dedicated for that. Avulak naha iti. Hari? But let's say your value of 2, 3, 60. You select this. Then how to reduce that 20? You have no mechanism. It's only addition. Making add mean difference column. So you have to always go for the lower value. Right. So I guess you got the basic understanding. So at home, just you can practice this. No need to give you example questions. Just write random questions. Now you can do this using log. Do this using log. If you want to make it more complicated, put a square like this. Now how do we do a square? Square kiyanne, let's say I want to find the square of this. Now you don't need to use log, there are shortcuts, but let's say square kiyanne this. So you find the log of this, find the log of this, add those two. But you can see the log values are the same. So I can say I find the log of this and multiply it by 2. So if you want to find the square of a certain number, you find the log of this, multiply it by this value, and then find the antilog. Similarly, let's say you need to find the square root, find the log of this, divide it by 2. Why? Because 2.5 square root is equal to the half power. See whether you can think why? Power, no, not multiplied by half, it's the half power. Bhaga veni balaya. Then you find the log of 2.5, divide it by 2, and then get the antilog. That's it, I think that's pretty much it. Now you know how to solve any log question, right? So I'll give you some random questions you can try. Let's say, if someone wants guidance, use your log simplification and send answers. Come on, these are not in my curriculum. But I can see how difficult it is for you if you don't know to solve. So, square root of 2.52. Square root symbol this. Then let's say 3.7 cubic root. Again, the 1/3 power. Make a samanai bang make it. Then you find log of this, divide it by 3, then antilog. Same thing. Hari? Boru tika clear again. Then at home try to solve these. Solve just random. No logic behind it. So can you remember here we made one mistake. So the antilog of this was 1.72 or something. Then don't forget to multiply here. This is the answer we got from the log part. We excluded this. You have this and you have this as well. Manually karan. So once you apply log, 1.72 times 5 times 10 to the power minus 2. Those were the two terms we left behind. Anyway, you can just try some things like this randomly. Remove the obvious parts like multiplying by 5, multiplying by 2. No need to apply log there. Again, multiplying by 2 is easier than applying log. Because the log of 2 is 0.3010. Adding the log value of 2 is difficult than multiplying it by 2 manually. Then we don't do that. Keep it. Simplify the difficult part, later multiply. But don't forget, I forget to multiply by 5. So remove the unnecessary parts, do those manually. Always make sure the numerator is larger than the denominator. It's always possible. By adjusting the powers of 10. Then you won't get any bars, no negative values. It's very easy then. Lazy. Then just apply the logs, add and subtract correctly. Apply the antilog. That's it. Now I guess you should be able to do this. before you forget, try to do this, especially the students who haven't learned log for their O levels. උඹලා කලින් කරලා නැහනේ. Then even though you feel you understood it, you might not. Once you are trying, you will get the real difficulties. Then again, you can write some more random questions like this and try to solve. What happens if we get it like this? Then always never use the calculator. Always try to use log. Then with time, these will be very trivial. Obvious වෙන්න ගන්නවා මේව ඊට පස්සේ. හරි. මොකක්ද තියෙන ප්‍රශ්න? Now you can ask questions. Thank you so much. Sorry. ඕක අහගන්න තමයි ඉතින් මේවා කරන්නේ. If we don't have a log table, ආයකට උත්තරයක් දුන්නනේ. Can you explain how to antilog එක තමයි දැන් කියලා දුන්නේ අර අනිත් පැත්තට ගන්න එක. So basically the previous antilog value for us was 0.2356. අරකම පිටිපස්සට බලන්න. 2356 මෙතනින්. So here 2355 ආව කියන්නේ 2355. So here it's 1.7 මේ column එක උඩට. That was 0 column, 1 column, 2. So that's 1.72. But this is correct if you get 0.2355. If it was 2.2355, the antilog of this part is this. මෙන්න මෙයාව represent කරන්න. To represent 2, you should multiply this by 100 because these are powers of 10. If this was 3, multiply this by 1000. If this was 1 point, multiply this by 10. එහෙම යන්න. Yeah, anything else? Why no one invents log table for power of 2? The ප්‍රශ්නය. Power of 2, why can't we invent? I think shape still it would work the same. මට එකපාර logic කරන්න හිතෙන්නේ නැහැ. Even for a log table using the base of 2, still the simplification should be the same. I'm not very... නෑ කරදරයි. Now the reason is then, that's a good question. If you have a log table for power of 2, you check the antilog for this part, and then to represent this part, instead of multiplying it by 100, you have to multiply it by 4. ආයෙත් කරදරයිනේ මං. You have to again do man. It's not like multiplying by 100 නේ. 100 10,000 is easy to multiply. Multiplying it by 2, 4, 8, 16 is again a difficult. මෙතන 4 වගේ තිබ්බොත් එහෙම then you have to again multiply it by 16. That doesn't work. That's a good question. හරිනේ? That's why we don't have log tables using base of 2. It's a good question. Why don't we use natural log? Same reason. Same reason. Now if someone doesn't know what natural log is, just ignore it. In maths you will learn. E කියලා term එකක් තියෙන අහලා තියෙනවද? 2.2356 වල වෙන්නේ if you have a 2 here, so this represents the power of 10 to the power 2. So you apply the antilog here, multiply it by 100. So if someone has issues again, just send me a WhatsApp text or you have the recording of this. ඒකත් බලා ගන්න. උලක් නැහැ. The most important part is මෙන්න මෙතන to do these questions. මෙන්න මේ ටික roughly කරලා මේ no need to send me the answers නේ කැල්ල එකේ ගහලා බලන්න ඉතින්. හරි? The answers can be a little bit different. The log and calculators are a little bit different, not that accurate log ඉතින්. පොඩ්ඩක් හිර වෙලානේ. හරි. Anything else? සමහත් තියෙන ප්‍රශ්න තමයි. So the session is almost over. I'm just answering your questions. Don't we need to write the simplifications of... No need to write not log. Any simplification is not expected and not awarded marks. Simplifications වලට ලකුණු දෙන්නේ නැත. It's just writing the equation, substituting with units, final answer with units for MCQs and just the answer. Okay, one more question. Hari. Now there are some questions. So if you think you got the idea, you can consider the session to be over. Thank you for joining and join next week. I'll let you know the plan. So basically we'll be discussing the remaining tute and then I'll be doing some simplifications ideas as well. If you have any feedback, just send me a WhatsApp text on our number because these sessions I can do anything. I don't get a payment for this. මට ඕනේ මම කරනවා. හරිද? So just let me know what you want to do. හරිද? Right. එතකොට මේකේ yeah, okay, that's a good question. What if we get a value like this? Hurry, I thought that would come 1.134 multiplied by 2.121. Hurry. So what you are saying is, it is impossible to make the numerator larger. Make ඒක නේ කියන්නේ. In this case, how can we make the denominator larger? I think right. You just apply a 10 here. Apply a 10 here and then put it 10 to the power minus 1. Right. Then this part is larger. Then find the log of this, find the log of this. The log of this is 1. That's right. That's it. Just to avoid that negative value. For some bar values are fine, I know, but most of you don't like bar values. It's right. So the log of this, log of this, log of this is 1. Hurry. Now this part is larger than this. Hurry. Understood? So I multiply this by 10 to the power minus 1. Then it balances. Then we apply log to this part, 10 to the power minus 1 stays. Harid, did you understand? The student who asked that question. Right. කවදාකවත් negative log සදන්නවා තේරුමන්නේ වැඩන්නේ. Can we round off the last decimal place if yeah, I explained that. Yes, you should, because you can only go for 4 decimals. If you have another decimal, round it off. Hari lamai. Then I think that would be it. Then we'll meet on next Friday. If you have any questions, send me a text. If there was anything and any feedback, let me know. I think things will be a little bit difficult, especially if you are struggling with logs and all. But if you have the courage, you can get this done. I'll help you. I'll be supportive. So it's I think so we'll have this QBR session every week, but we'll start at 7:30 and we'll have to finish at 9:30 because the 27 students have their QBR at 9:30. Then we'll meet at Friday. Thank you for joining. Good night. See you. Bye bye. If you have any questions, send a WhatsApp text, okay? And I'll end the meeting.